This week, Yvonne Arce, Chief Research Officer at Quarkslab, joins us to discuss supply chain security and TPM 2.0 vulnerabilities. In the security news, blizzards, sleet, typhoons, sandstorms, and tsunamis. Masking your car, stealing tech in a Nokia phone, killed -64. Google doesn't want to fix an RCE. I kind of don't blame them. Hijacking packages, monitoring Macs, beating roulette. Lame advice from Microsoft. Our post-authentication vulnerabilities, even vulnerabilities, ghosts, burp, GPT, and do you trust Google? All that and more on this episode of Paul's Security Weekly. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. When organizations face poor web performance, challenges building modern applications at scale, or need to reduce operational and development costs, they turn to Fastly. Fastly's distributed edge network means your business can unleash its growth potential without worrying about scaling your infrastructure, whether growth of users, transaction volume, or geographic expansion. Get the speed, security, and edge cloud innovation you need to deliver profitable and engaging experiences. Visit securityweekly.com/Fastly for more information or to speak to an expert. Welcome to Paul's Security Weekly. It is episode number 781, being recorded on April 19th, 2023, right here in G-Unit Studios in Rhode Island. Miss Mandy Logan has joined us this evening. Mandy, welcome.
Why, thank you. And I'm very, very interested. Among the many things that Yvonne has done, I really want to know his core reaction to cybersecurity versus InfoSec, the word.
Yes. We will dig into that topic. Here to help us with that is Mr. Josh Marpet. Josh, welcome. That's Josh talking, but forgetting to push
without the damn mic on. I'm sorry. Time for semantics today. Let's do it.
It even has a light to let you know it's muted.
Mr. Adrian Sanabria has joined. Adrian is here again this week because he loves Paul Security Weekly so much he just had to come back.
I do. It's true.
You don't have to do all the primary hosting duties this week. Which
very,
is
very different experience. And I do
tell people, Adrian, tell people how much work that is to fill my shoes on the show. I'm just kidding.
Not as much work as doing ESW.
Is that so?
We got 2 interviews. You're a 2-segment show.
I know, this is true.
We're a 3-segment show over there, man.
That's why I passed that show off to you, because it was too much work. Oh, boy. Security Weekly listeners will save $100 on their RSA Conference 2023 full conference pass. If you haven't bought your RSA pass by now, you're kind of late to the party because it's really soon. Taking place next week, April 24th through the 27th in San Francisco and on demand. To register using our discount code, please visit securityweekly.com/RSAC 2023. Use the code 53UCyber. I will not be there. Adrian will be there. Josh will not be there. Mandy will not be there. So there. You get to see Adrian and all the Security Weekly hosts, but not me. Yvonne is the Chief Research Officer at Quarkslab, where he leads a cross-functional team that coordinates all of the security research of the company. He is an industry veteran with over 30 years in InfoSec, and he states now known as cybersecurity community. He co-founded Core Security Technologies, an Argentinian cybersecurity company in the mid-90s, and was a very early guest when we were called even something different back that far. Yvonne, welcome back to Security Weekly.
Hey, hi. Good to see you.
Nice to see you too, my friend. It's good. I'm sad that we took this long to have you come back on the show. What were you thinking? We should have had you back on sooner, but I'm glad you're here now.
I hope I'm wiser now. Now that I'm older.
We hope. We all hope as we get older.
We can only hope.
We get wiser. So we certainly get a lot more gray in our beards as we get older.
Exactly.
So, Yvonne, tell us about your journey after core security. I think it's a good place to start because, I mean, you talked about the core security journey a lot in previous episodes.
Oh, yeah. So, yeah, I left so I founded Core Security with a few friends in 96, I think, something like that.
Mm-hmm.
And I left the company in 2011, 12. So that was like a good ride, 16 years. And, when everybody that I know that has worked, long enough in the industry comes to a point where they just want to leave the industry at some point in time. And that was, among other things, what happened to me. I thought that the industry and the whole cybersecurity thing was moving in a direction that I didn't like that much. So I decided that I wanted to do something else. So I left my company and I went to work for an NGO, a not-for-profit foundation here in Argentina, to build. I still work in security to build or to create a research group inside this foundation that was dependent of the Ministry of Science in Argentina. But it wasn't a commercial endeavor. It was not something that was associated to the industry itself. It was still doing security research. It was doing it in not-for-profit, and it was in Argentina. And I was sort of detached from the whole global industry. So I worked there for 5 years. And then just when I was getting out of it, they pulled me back in, sort of. I met Fred, the CEO of, I have met Fred probably in the 2000, 2002, something like that, like many years ago. But I reconnected with him. Fred is the CEO of Quarkslab. Because he was looking for some help to set up a subsidiary here in Argentina because he was hiring some people for his company. Incidentally, they were ex-core people, so I knew them. And I said, oh, that sounds interesting. So I learned a bit about the company, and I liked it. And it reminded me a lot of the early years of Core, and it had the same technical excellence and the same passion and the same ideas about combining offensive and defensive security, offense and defense, and how those two things work together, and so on. So one thing led to another, and eventually I joined the company, and that was in 2016. And I've been at Quarkslab since then. So that's what happened.
What does Quarkslab do today, Yvonne?
So we do services. So we provide vulnerability research, reverse engineering, security assessment, source code reviews, like assessment of the security of your product. If you are a product vendor or manufacturer or so on, not just software, we do a lot of like lower level stuff. Or if you are an organization that actually buys these products and wants to deploy them on your infrastructure, usually you hire services to do assessments. So that's what we do. And we also have some security products. One is for application self-protection, like self-protection for mobile apps or for IoT, particularly IoT firmware or applications. Like obfuscation, data and code integrity checks, environmental checks, remote attestation, all those things are wrapped into a product that we sell. And then we have another product that is for malware detection at scale or file analysis, binary file analysis at scale that runs on Kubernetes. So it's sort of like a, virus total, but runs on your own Kubernetes deployment in your cluster or in the cloud. and you can add your own analysis engines to it. So we have those three things. They are all quite interesting things from the technical perspective, right? There's like a huge surface of topics or a huge number of topics that you can dig deep into to do research work.
Yeah.
So it's quite interesting, quite exciting.
One thing I wanted to dig into, there's a lot of options here, but I'm going with the vulnerability disclosure process, because you've been very close to that for a really long time. Probably like one of not a lot of people that have been that close to it for that period of time. How has the landscape changed, and what are your thoughts on disclosure in general today?
Wow, so that's we have an hour for just that question. So yeah, the first bug I reported was in 1996 in a DNS server, byte. So that was the first time I reported a vulnerability, and I've been doing that since then, like coordinating vulnerability disclosure processes with vendors, the things that either the ones that I found, sometimes I find something, but it has been like quite a long time since I done bull research myself. But at Core, at the NGO that I told you about, at Quarkslab, I coordinate a team that is responsible to coordinate disclosure, report and disclosure with vendors. So anything that anybody at the company, any bug or vulnerability that anybody at the company finds, when it's time to report it to a vendor, there's a dedicated group that manages that process. So I have a lot of experience of that, and it has changed quite a bit, but not uniformly. So when I started, it was like really difficult to get traction, and people will ignore you or threaten you or just say, shut up, don't talk about this or else, or like there were many different ways of pressuring people that were reporting. You have to, but on the other hand, they didn't like you when you publish details about the vulnerability. So they try to block you from publishing the details, and at the same time, not act on what you were reporting to them, which is a bit like, not it doesn't make much sense. And I was originally, even before Core, even before I got in the security industry, I was on the receiving end of bad vulnerability disclosure or bad vulnerability reporting, because usually I was before security, I worked on computer telephony integration companies. So companies that would deploy systems that connected telephony networks. This is like telephony from the old era. I know most people watching this.
Yeah. Just for our younger audience, you used to have a phone in your home that was connected to a cord that plugged into the wall. That's how we called it.
And that was connected to a whole network of telephony switches, right, that were not on the internet.
Except when they were.
Exactly. And there was the computer networks.
Yes.
Like that, right? So there were systems that connected both things. You put a server and connected to both networks, and you could do things with this system. So I was in that industry. I was deploying and developing and deploying those systems and configuring them, and then connecting to the phone switches and having to interact with the phone switches with a program, like do something that's called signaling to root calls and so on, and then connecting to the computer networks and having to interact with servers to obtain data from services and then pass it on to the telephony side and so on. So none of these things worked because it was very early. It was the early 90s, and they were all riddled with bugs, and they were all these things were telephony cards that you put in your server and had firmware that implemented the protocols, and they were all buggy. And so when I called the manufacturer, several manufacturers, the most common one was the most known one was a card manufacturer in New Jersey called Dialogic, which was acquired by Intel many years later. asking for solutions, for support, or for like a bug fix. And they would laugh at me because I was calling from Argentina and I wasn't like some insignificant guy in Argentina. They didn't care about my bugs, right? So I have to reverse engineer things and fix the binaries myself and fix things myself and have no information whatsoever about the bugs or the fixes or the patches or anything. So from that experience, I suffer the lack of information. So when I work in security, I made it was like, for me, it was obvious that when you find some problem, some vulnerability or some bug, you needed to provide full details to the potentially affected audience, because that's what they need to solve the problem, right? They may rely on the vendor itself, but when you report a vulnerability to a vendor, let's say you find a bug let's use Microsoft as an example, but it applies to any big vendor, big or small. You find a vulnerability, you report it to the vendor of the software, because they are the ones that are in the best position to fix it. Right? They have a source code, they have the build system, they know the code, they have the engineers that develop the code, so they can fix it. You report it to them, you give them details, you are giving them a monopoly on the ability to fix the problem. Should that monopoly be forever? Like, should be a permanent, forever monopoly that nobody else knows about it and just wait until the problem is fixed? And my opinion is that the answer is no. They have the opportunity to fix it. The vendor, the official vendor, has the opportunity to fix it. They have a monopoly on the ability to fix it for a certain time. But if that doesn't happen, it is not only fair, it's necessary to open up the details to other people so they can fix it themselves. Either somebody in the security industry that can provide mitigations or provide some ways of workarounds, or implement those mitigations on some particular environment or some specific network from customer, or even the end customer itself, like I was in the early 90s. I could read the details of what the problem is and figure out how to solve it myself, because I couldn't rely on anybody else to do it for me, right? But for that, I needed the technical information. So that's the approach I take to.
But Ivan, in this process of full disclosure, it also gives the attackers the same information.
Yeah.
And that's what people argue.
Yes.
I agree with you we need the information so we can apply mitigations. But those that would argue the counterpoint would say, well, the attackers now also have this too.
Oh, yes. And I've argued that I have had that argument for 30 years. So I'm very well prepared to address it, I hope. Yeah, you're right. It does give information to the attackers, but guess what? The attackers need less help from me than the defenders to figure out the details. And I know this because I've done it.
Yeah.
Right. We have done that. We have reverse engineered patches to figure out where the bug was, found the bug, wrote the exploit for it, shipped the exploit to our customers so they could test their defenses. So
I remember that. I used to use those exploits. Also, a great example I like to use in this case, Ivan, is Maddie Stone's account of reading the marketing materials from, I believe it was a piece of Android malware that like briefly described their vulnerability and exploitation, and from the marketing materials went into the Android source code and found the bug and fixed it.
Yeah. What I think is smart attackers, and we shouldn't presume that attackers are idiots. They're very smart. Some of them are idiots, like in every community. But we should assume that these are intelligent people and they are smart and they can find out things by themselves. So they don't need that much help. The vast majority of the security community are defenders, and they probably are more in need of our help than the attackers. So
now, I want to get on something that really grinds my gears, Ivan, because I want your take on this, and I have some recent examples. And this is an example of like once we've disclosed the bug, and they've fixed it and released a patch and disclosed it. the rub is like how they classify it. So recently, even recent examples, Intel, Microsoft, and Ubiquiti all tend to treat privilege escalation, post-authentication vulnerabilities like privilege escalation, a couple different variations of it, right, as either not a bug or not a priority. Microsoft has a history of approaching privilege escalations like, oh, if an attacker's on the box, they're on the box, like game over. Intel will classify a authentication bypass as privilege escalation, which I think, so like their whole thing is like you don't have privileges, and if you exploit an authentication bypass, then like you have privileges, so therefore it's privilege escalation, which is just confusing. And Ubiquiti has come out and said, well, you know, anything that happens post authentication is not a vulnerability. And I know those are like
okay, but that means I mean it makes sense. It only makes sense if you specify what are your security boundaries, right? What is your trust model? So if, like, for example, like, let's think about the old days, Windows 95. If you're logged in, you are God. So therefore, privilege escalation is not a problem. It's like,
you're either
right?
you have it,
right.
The privilege is binary, right? Either you have it or you don't.
Exactly. But if you have some trust boundaries on the system, then it's not fair to say if it's post authentication there is no problem with this, because that implies that once every user has the same privileges on the system, right? Every authenticated user is a god or root or administrator or whatever, and that's usually on modern systems. That's usually not the case. So there are some internal boundaries. So if a security boundary is crossed because of this bug, then it should be considered a vulnerability. And then we can talk about CVSs, but maybe it's not a good idea to talk about CVSs because everybody hates it.
It's that, you know, but it's that classification. CVSS is an example, and everyone kind of has their different take on classification, and I think it's one thing that could put people in a compromised situation, right? Or perceive the impact of a vulnerability in the wrong way, basically, which I think is more dangerous than the full disclosure and, you know, like everything's out there kind of thing.
So if I can just
because, you know, CVSS it's an attempt to simplify your understanding of vulns. So you are reducing the complexity of a vulnerability into a number, a quantity, because people like CISOs or CFOs or other people are used to handle metrics and numbers and prioritize things based on numbers. They don't want all the complexity of understanding what is the vuln, what are the privileges, what are the conditions to exploit it, what are the consequences, or all these things. So just give me a number.
Yeah, and a number from 1 to 10, right? Because that's
exactly
that's how we think.
A number from 1 to 10, but with some modifiers. So it could be like 7.68.
Yeah.
But it could never be 7.8 because the formula doesn't allow to so it becomes not a uniform space either. So when you start to model that, you start to introduce some constraints and limitations. And if you don't understand them, then you will just use the number in whichever ways you want, or you will tamper with it like Oracle. Did I say that? Sorry.
Did you say Oracle? Is that what you said?
I don't know. I didn't hear myself. So.
Sorry, Adrian has a question.
Yeah. Just I wanted to expand on Paul's point here.
Or I don't hear him.
Oh,
you can hear me?
Yvonne cannot hear Adrian.
Hello. Test.
There's a slider on the mix going back to Yvonne that needs to go up. Test.
Can you hear me?
Just FYI, Adrian, I can hear you.
I can hear Adrian.
CVSS, cyber.
I cannot.
Big data.
ASL, what?
He's spewing buzzwords now.
Kubernetes.
Oh,
quantum.
There
it is. Okay. We found the slider. Okay. Adrian, continue.
I figured if I said enough buzzwords, it would just start working.
Or stop working.
or stop working. Yeah. So Ivan, kind of my question, expanding on the CVSS score, something that's always bugged me, and I'm curious if you have any opinions on how we can fix it, is the fact that you can have like a CVSS 9.8 that's RCE, that's denial of service, that's privilege escalation. Like there's all these different kinds of exploits that have very, very different impact and ramification. I don't think you can do it with a score because it depends on where you're using that software that determines, if RCE is the worst thing or if maybe privilege escalation. Like, if I'm AWS or Azure, I'm very concerned about privilege escalation because, there's a lot of customers sharing equipment, right? If I'm running a, League of Legends, maybe I'm really concerned about denial of service because availability is the most important thing to me, even more important than remote code execution. So, and it always pisses me off how deep I have to dig into a vulnerability report to figure out is it, what's the attack type? Do I already have access to the system? Do I, is it, no credentials needed, no authentication, remote code execution? I hate having to hunt for those things.
So my view of that is I have several opinions of that. I have plenty of opinions about many things. So, but my view on that is that so first CVSS is wrong, and everybody hates or criticizes CVSS, but it's something that we have, right? Before CVSS, we had nothing, and it was even worse. So, okay, so we have a score from 1 to 10, whatever. It simplifies things a lot, and it's possibly not very good at many things, but people use it worse. Like the use of CVSS by many people makes it worse. Right, because they just use it to prioritize in a decreasing order from 10 to 1. Let's just prioritize in that order without context, without applying any sense to the actual environment where they are applied. But there's something worse, even worse than that, which is we are overly fixated on vulns or thinking about vulns and not about attacks. Because the view of vulns, it's a flat view. It doesn't have any depth. It's like a list of vulns that we need to fix. And what you need to think is how these vulns can be combined to build attacks into my systems or my network or whatever I'm trying to protect. And then and when you do that, that's when you figure out what are the attack paths that you need to address, not the specific vulns. Right, and at least that's the way I look at it. And I think that in the past decade, I've been saying this for like maybe 15 years or more, but in the past decade, there has been some advances in that direction with MITRE attack framework and with other things. So CVSS and the vuln view of things is just a building block for that other thing, in my opinion.
So wait, Ivan, what you're saying is if I patch everything that's a CVSS score 8.0 or above and I got coverage in the MITRE attack framework, I'm unhackable.
No. but let's try. No, but let's try.
There's no CVSS for credential stuffing, right? There's no CVSS score for phishing.
But what Ivan's saying is that that's covered largely in the MITRE attack framework, right?
Right. Yeah, right. And what I'm saying is you need to figure out how vulnerabilities and attack techniques are combined into actual attacks. And you may not need to fix every CVSS 8 plus in your infrastructure. So you just need to make sure that the attacks don't work.
So, but what you're saying is everyone needs a penetration test, going back to your days at core.
Well, no, I would not glorify penetration tests. I think they are a valid component of a security strategy. They need to be done. when I left Core, what we were working on was to do it automatically. Now there's an industry or a segment of the industry that does that.
Yeah.
That it's like constant, continuous penetration testing by automated software.
Right.
Not
breach and attack simulation, right? Yeah.
Exactly, that kind of thing. So, and I think that is eventually, because of scaling problems as well with the current infrastructures, and because of the fact that we have a big chunk of our infrastructure on different cloud providers, and the need to cover all the bases, eventually that's going to be possibly a very valid solution, like vulnerability scanners were in the 90s.
Mm-hmm.
The next thing is to have something that is constantly attacking you, and not humans. Maybe it can be driven by humans, but it just doesn't scale to do it with humans, with humans, right? So, yeah.
Yeah, we've got a lot of new categories there, like breach and attack simulation and
attack surface monitoring.
Yeah, external attack surface monitoring. Yep.
Yeah,
so
that kind of thing. Yeah.
That direction, right?
Mm-hmm. Yeah.
Yep.
Yeah, I think that there's a lot of value in that kind of thing. I'm not in that industry anymore, but I think there's a lot of value in there.
So what we're coming down to is going back to the original question is I think I got a right to be agitated by vendors downplaying local privilege escalation. I mean, let's take Microsoft as an example. A lot of their advice and other people's advice about Windows operating systems is, well, you should just, have users pick good passwords and do monitoring. And there's a lot of ways to escalate privileges on Windows, but like, who cares? Now it's on you to monitor for that. And I don't necessarily buy that.
Yeah, but again, it depends on the environment where that happens, right? And because I don't think they underestimate privilege escalation on the cloud environment.
Yeah.
Like, for example, a virtual VM escape. They actually care about those things, right? They don't say, okay, if you're running a VM on Azure, then, well, it's okay. It doesn't matter if you can escape it, right? They do care about those things.
Right.
So it depends on the context, I think.
Yeah, I was talking about Windows specifically, right? Because then, that gets into, you mentioned firmware earlier, right? That gets into how deep on the system can you persist as an attacker. And one of the safeguards to prevent an attacker from persisting that deep, a lot of vendors kind of throw their hands in there and like, yeah, that's going to happen because you let an attacker on your system.
Okay, but then like we have SGX or we have the TPMs or like the secure elements and that kind of thing that are supposed to be resistant to attackers on your system, right? So there's an argument there, like there are trust boundaries inside the system, and if they are violated, then there's a security problem, and you cannot deny that.
Yeah. No, and I completely agree, because what attackers I see are doing is eroding those levels of trust deeper and deeper down into the system, which is a good segue into TPM. And it was your team, right, that discovered vulnerabilities in TPM 2.0. Ivan, can you just give us like a high level of TPM and then kind of delve into the vulnerabilities that were discovered?
So TPM, it's a discrete chip that you have in your system. It's like a separate chip that you have, there's different implementations. But for now, let's say that it's a tamper-proof security chip that you have on your system, your desktop or your server, that performs some very basic operations that upon which the trust of the entire system is built. Like, for example, when the system boots, this chip performs the operation needed to verify the integrity of the rest of the system, to make sure that it wasn't modified, or the operating system or the bootloader or the different components of the system were not modified or by an attacker, or the integrity was not.
It plays a critical role in UEFI secure boot.
Exactly. It can also store encryption credentials. Like, for example, if you have full disk encryption on Windows, BitLocker, the keys to the key to decrypt your disk, it's on the TPM and it's stored there, right? and it can perform cryptographic operations, encryption, signing, other things like that in the chip. So basically, it's a secure element on your system that you can rely on to perform security-sensitive operations and to make sure that and to be sure that it was not compromised. And this is done by software. In this case, it's firmware. The firmware and it has an API, so the operating system can connect to it and request operations like send requests, get results. And this API is defined it's an open API that is defined by the group called the Trusted Computing Group that is formed. It's a consortium of big vendors, chip vendors, Microsoft, Google, Intel. There are several of them, and many chip manufacturers. So there's an open API. There's a reference implementation in the API documentation. There's a few open source implementations of the API, one from IBM, another from Microsoft. And then there are chips, hardware. So as I said, manufacture chips that you put in your, you don't put them. You could buy it and put it in your system, but usually if you buy a laptop today, it comes with a TPM in the motherboard. Same with a server. There are some implementations that are just firmware on the CPU, like from AMD and Intel. They have, instead of having the separate chip, they have the firmware in the CPU. And then there's another thing, which is cloud providers. Because the cloud provider has to run or has to offer the possibility to run a virtual machine running, let's say, Windows 11. Windows 11 requires a TPM on your system to run. The cloud provider needs to give your virtual machine a TPM, a virtual TPM. So it appears to be a hardware chip for the virtual machine, but it's in fact implemented purely as software. So all the cloud providers, Google, AWS, and Azure, and I think Oracle as well, they all have virtual TPMs on their cloud provider offer, and they even offer some extra secure virtual machines, isolated virtual machines that then the names vary, that make use of this TPM. Mm-hmm. So that's the intro about TPMs. And it turns out that one of my colleagues found 2 bugs in the reference implementation that is in the specification of the API. And because it's in the reference implementation, it was very likely that people that take the reference implementation to do their own implementations will copy that. So therefore, we suspected that the problem cascaded into who knows how many different vendors, and that's what happened.
I want to stop you there because I think we've shattered the notion that with more eyes, all bugs are shallow. Because what you're saying is a lot of people, everyone had access to this reference code. We had a number of manufacturers implement the reference code, and no one found this bug. No one looked for bugs in it. No one found it, and it was there.
Well, not no one. My colleague did.
Yeah, your colleague did.
But yeah,
one person did, which is important to the story, very much so.
Yes.
But also when we see reference implementations of things like this, UEFI, being also another example, right? What we often find is the actual implementations they extend, they don't often rewrite or modify much of the reference code. It's a very generic statement.
It's common that it's not written from scratch. They take the code that exists and they modify it and adapt it, but it's very common that it's not written from scratch. Yeah.
So given all of that, we know where the story's going. Your colleague found a bug in the reference code, which likely means it's in all or most of the implementation.
So it was interesting because he started with the fact that Windows 11 requires a TPM to run.
Right.
So he looked at the virtual TPM code because he wanted to run Windows 11 on a virtual machine, at the virtual TPM code of Microsoft Hyper-V, and he found the bug. But then he said, okay, but I'm going to run this on QEMU. I think it was QEMU. So, and there was an open source, QEMU uses an open source implementation
Yep.
of TPM. So he found the bug there too. I said, oh, this is strange. So then he looked at the reference implementation, and in the documents, the code is in the specification document. So he found the bug there as well. So now he understood that, oh, this is where it comes from.
Mm-hmm.
So then we thought, okay, so if it's in here, it's very likely that it's in several other vendors. And that's when we contacted CERT, because we couldn't possibly, I mean, I reported it, we reported it to Microsoft, we reported it to VMware, but then we decided to contact CERT to try to coordinate with all the potential vendors. We couldn't even map who was vulnerable, who wasn't, who could be vulnerable.
Mm-hmm.
So that's what we did. And this was in November of last year. So it took us some months, but it was more or less okay.
Yeah, process. That's not bad. That level of coordination, that's a good timeline in my, 18 years of covering
the problem leaked twice during the process.
Mm-hmm.
So, and I know many people said, "Oh no, it's terrible," but I have a lot of experience with these things, and I didn't expect different. It was really very complex.
Yeah,
as I said, I've been reporting bugs since 1996. And this was very likely the most complex process I've done.
Oh, interesting. That's interesting. I didn't know. I was going to ask you, like on the scale, this was the most complex.
It was the most complex, but it was not the most stressful or the most dangerous, because I've been threatened by the general counsel of some public company to retract my statements immediately or else in the past. And in this case, it was handled like it was, all things considered, it was smoother, quite smoother than that.
There was no threat, because now there's hardware or OEM chip manufacturers, I should say, that have to update their firmware for the TPM hardware that then has to get rolled out. And this is where we start segueing into the whole supply chain aspect, which is a very broad and encompassing term. But in this case, it's in an area that I'm pretty comfortable with, and that is, there's the company that makes the software, there's the company that makes the chip, there's the company that takes that chip and puts it in their motherboard, and then that motherboard has to go to like a Dell or an HP, and they're incorporated in there, and then there's a lot of hands and a lot of cooks in the kitchen. It's just as an anecdote, this is an interesting anecdote, because one of the chip vendors during the process told us that they were not affected. He said, none of our current products are affected. So I said, okay, fine. We have no way to verify this, right? Because it's not possible to debug a TPM to figure out if the bug is present or not. We don't have debugging tools. We don't have logs or a console to look at it. So I said, okay, fine. But we were thinking about, how do we test if a chip is vulnerable or not? What are the things that we could do? So we had a POC for it. So I ran the POC on my Dell, on one of my laptops, on a Dell laptop that had a chip from that vendor, and it turns out that it was vulnerable. So I go back to them, and I showed them the log of the POC, and they replied to me and said, okay, yeah, but that's a very old version of the chip, and it's end of life, so we are not going to patch it. And I said, okay, that's fine. Who am I to tell you what to patch or not? I'm just saying my laptop is vulnerable. But I said, okay, so the chip in my laptop may be end of life, but the laptop itself from Dell is not. So you may expect Dell to ask you for a patch to your firmware, right? So it becomes a very complex thing. Because you may not even know that you have this vendor's chip on your system. Right, you just bought the Dell or I don't know, Lenovo or whatever, and then you need to figure out what is the TPM what TPM vendor is it's on my laptop on this model or in this other model, and what version of the firmware it's running on it. So it's very complex. Yes, that's where we get into generating an SBOM for not just your laptop, but all the components and subcomponents, and then firmware that's running on those on those components, and it gets very complex. And this is an interesting situation where, like, so do you know if Dell actually went to the chip vendor and then rolled out a fix? Because Dell would, this thing that gets me right about this is like Dell has to push that fix out, right? Because they have to make sure it's compatible. They have to apply the fix and hopefully do some testing.
You cannot expect like some random guy to go to the chip manufacturer's support page to download a firmware update for the TPM, right? It has to come from as Dell. An update from Dell or from even from Windows or Linux, right? Not even that.
Yeah. So that, and this is an example of my Spider-Man meme supply chain slide where it's all the Spider-Mans pointing at each other. And on the heads of all the Spider-Man, it's Microsoft, it's Dell, it's HP, it's Intel, it's whoever the TPM manufacturer is, it's Linux, and they're all just pointing fingers at each other. Like, I don't know whose job.
But they're not even the head, because they also use these chips from the vendor. So they are like, it's like there is a really good graph that I want to steal from Halvar, Thomas Dulin, that he did at some presentation. I need to track it down so I can steal his slide because I will use it in some presentation that I'll do next week. Where he shows a graph of, he talks about supply chain security, and he shows an hyper-connected graph where every node is connected to each other.
Yes.
Right. So it's more like that. It's not a tree. It's like a hyper-connected graph, mostly. So,
what's the severity and impact of these TPM vulnerabilities, Ivan?
You mean in CVSs terms?
Yeah. What's the CVS? No, not the CVSs score.
No.
Like, if I were an attacker and I were to exploit them, what does that get me?
No, it depends a lot on the implementation. It's very dependent on the implementation because it's the same code, but it's implemented in different ways. Like, for example, in the case of Windows, of Hyper-V, that runs on your Windows system, they have a big buffer, so you can overwrite. It's an out-of-bounds write and an out-of-bounds read. So you can read from the TPM memory, or you can write to it 4 bytes or 2 bytes, 2 bytes. Past the boundary, so you can write 2 bytes to the TPM memory.
Now wait, I'm sorry, Ivan, when you say the TPM memory, you mean like protected a region of memory that the system CPU sets up for the TPM?
No, the TPM
on the chip,
itself.
The memory itself on the chip. Okay.
Yeah, where the code is. So it's either a leak of data from the TPM memory, which is bad because it's supposed to have sensitive information. Yeah. Or it's a code execution on the TPM, which is also bad. But this thing depends heavily. It's very implementation dependent because it depends on how the vendor has implemented the buffer to store the commands that are sent to it. So it could be a global buffer that is initialized to 0, and therefore then the problem is not that big, or it could be an allocated buffer that is the size of the command that was sent to it, then the problem would be severe, or it could be a buffer that is fixed in size, but it's twice the size of the command, so the problem could. So it depends a lot on, and the problem with this is that it is not easy. It is not easy to debug this because you don't have a debugging facility for TPMs, at least not. I mean, the vendor may have it, but we don't have it. Right. So.
Yeah, because
you cannot debug, you cannot step by step the instructions on it. So it's sort of try to exploit things more or less blindly, like a black box.
Mandy, I think that went to your question because I think in some cases there was a 2 byte buffer. You pulled that out. You had some questions like, what do you do with 2 bytes? Is that even possible?
I did in reading. Yeah, I was curious because now I have to find that write-up again, but I was curious what he felt like would be done, or like from his viewpoint and his experience, what would he do with the 2 byte?
So last year, some other colleagues found a vulnerability in the Titan M chip from Google. Titan M is a security element that you have on the Pixel phones.
Yeah.
And we have a blog post about that one too. And the vulnerability allowed you to write a single byte with a fixed value of 1 an offset, and not everywhere in memory, to certain offsets of memory. So, and that was sufficient to achieve code execution on the chip. Right. So it could imagine that you can only write one byte with the value 1 at some ports, at some places in memory, not everywhere, or not anywhere. So at some specific places, and that was sufficient for code execution on the chip. So you never know, right? You should assume that if you can write to memory arbitrary values, it's a game over, unless there's some evidence or like a lot of substantiated evidence and research to disprove that hypothesis. Because in general, it may be hard. It may be like it may take you a month or 6 months or I don't know, a year. But the assumption should be, and some people may have the time for that. Some attackers may actually invest if the return is worth it. They may invest that effort into it. So.
Yeah, it's really, especially when we're talking about a TPM too, and a high value target, attackers may invest that time.
Yeah.
So because of that, do you agree then with Microsoft putting it as a low risk?
I'm sorry, I didn't get the last part.
I'm sorry, I'm having audio problems too.
Yeah.
I think Mandy's question was, do you agree with Microsoft putting that at a low risk with the 2 byte, given the 2 byte buffer?
But they didn't. They actually issued a bulletin and they rated this as critical. So in the case of the TPM bugs, they are rated as critical, and so they actually consider it critical. Yeah.
And this allows an attacker to get code execution on the TPM?
Yes, depending on which TPM we're talking about or which implementation. Yes. Like for example, in QEMU, you can exit the VM.
I got you.
In Hyper-V, it's not. We have not verified that that's possible. It's possible. It's probably not possible. But in other implementations, it may be.
That's awesome. That's awesome. So what do you do, Ivan? What did you do with your Dell laptop? Did you throw it away? Because you can't fix the problem.
Well, it's there's no workarounds either. There's no not mitigations, because any user space program should be able to talk to the TPM, or the kernel should be able to talk to the TPM as well. So, and there's no way to detect a potential attack. Actually, there is a way. In my case, when I run the POC, the TPM stopped working, and because I have on this system I have Windows and I have BitLocker. When the TPM stopped working, I rebooted the machine, and it went to the BitLocker recovery mode because the TPM was not working, so I couldn't do the operation needed to decrypt the. But then I hard rebooted it, disconnected it from power source, and then I put it again, and then it started working again. So that way, it was possible to know that that my chip was vulnerable and that it was actually attacked by me, of course.
Right.
But it may not be the case in every case. So you just learn to live dangerously. That's what we do. I mean, we know that the systems that we work on and that we use every day are vulnerable and have a lot of bugs. And so we don't set them on fire because of that, because otherwise we couldn't be we wouldn't be working on this in this
right
industry.
Yeah, no, I get you. I think it's just what you're saying, Ivan, is monitoring and diligence, it does pay off, because there's always going to be some vulnerability on some aspect of your system. Got to pay attention.
Yeah. I mean, it doesn't mean that you just don't care. It means that you need to pay attention and figure out if there's something going on with your system, and look at the indications of compromise or events that may indicate something's going on, and then you can dig deeper. But that's how the way it is. I don't expect to have fully patched systems, every system fully patched all the time. So
More questions for Yvonne? Yvonne, it's been so long since you've been on. I don't know if we were doing 5 questions when you came on.
I don't know. I think the last time that I was on, we had a discussion about the Gen 2.
Yeah.
Yeah, but that is very in the past. We all agree that nobody does that anymore, right?
So I got 5 questions for you that you probably haven't answered before on the show. You ready, Yvonne?
Yeah.
3 words to describe yourself.
3 words. Curious, contrarian, I don't know. I'm curious. I'm naturally a contrarian, and I am a team worker. I like to work with people, not so much alone.
If you were a serial killer, what would be your weapon of choice?
A spoon, I guess.
If you wrote a book about yourself, what would the title be?
No, I wouldn't. I wouldn't. I don't know. I wouldn't write a book about myself. I don't know.
So, like, I didn't write this book would be the title.
Maybe.
I did not approve this. This is not mine.
Or maybe. I have this book. I haven't read it yet. I have it I took it on vacation. I was supposed to read it, but I read something else. That it's what was it? Success through failure, something like that. Like how failing repeatedly provides you success. So my book would be Failure Through Success or something.
Nice.
Yvonne, no, I don't know.
No, it's true. Yvonne, what is your favorite hacker movie?
War Games.
Nice. Choose 2 celebrities to be your parents, alive, dead, fictional, or otherwise.
Choose 2 what?
Choose 2 celebrities to be your parents.
2 celebrities.
These could be celebrities in your own mind. It could be really anyone from popular or not so popular culture, history, fiction,
2 celebrities
science
to
fiction.
be my parents. No, man, I don't know.
Say
because,
Paul and Adrian. Paul and Adrian.
Captain Kirk and Spock. I mean, could be, if you're a Star Trek fan.
So, Rick Deckard and what's her name? Sophie is her name, right? You know what I'm talking about?
No, I won't lie to you and say
Blade Runner and his replicant.
Oh yeah.
Girlfriend.
Yes. Very nice. Yvonne, it was so nice having you back on Security Weekly. Thank you so much for your time today.
Thank you. Nice talking to you again. Goodbye.
With that, we'll take a short break. Come back with the security news. Stay tuned.